Okay, I see the recording has started. Thanks so much, everyone, for joining. My name is McDonald. I am a product manager for Exchange Online, and I'm joined today by Denis Signorelli, who's a service engineer and helping run M365 services. And today we're going to be talking through some email security methods and some features that can be used to address gaps in those security models. Go ahead and switch to my deck now. Okay. Okay. Yeah, so we'll be talking through two email security methods today and some challenges with those current security methods. And then we'll look at two features that can be used to address those challenges. So first, MTA STS, and then SMTP DANE with DNSSEC. So we'll do a look at the roadmap, what's available, and then what's coming still, and do tech deep dives for each feature. And for MTA STS, Denis is going to do an inbound configuration walkthrough so that you can see how you can use MTA STS to configure, how you can configure MTA STS to secure your inbound mail flow today. Okay. And if there's any questions, feel free to put them in the chat. We've got a team of moderators from my team, and they're awesome, so they'll be happy to answer any questions you have. And then at the end, we'll have a couple minutes for Q&A. Okay, so for the current approaches to email security, so there's on the top, we'll see end-to-end message encryption. So this is where two organizations share key pairs, and the sender on the left fully encrypts the email before sending, and then the recipient has to decrypt it on their side. But this has a lot of open standard and scale issues, right? With sharing these key pairs securely, and then how do you do rollovers, and then you have to share them with everybody you're communicating with. It's pretty difficult to implement. So then we look at the hop-to-hop message in transit encryption. This is typically bootstrapped with TLS, start TLS, which is opportunistic by design. It's really just an SMTP command. It's sent in plain text, and because of that, it's vulnerable to downgrade attacks. And this is where a sender issues start TLS to the recipient email server, but someone on kind of in the middle is able to manipulate the response, and so it looks like that destination email server doesn't support TLS, and then automatically the connection is downgraded to plain text or a lower version of TLS. And then there's another issue with SMTP based email is that there's no protection against DNS, and there's a lot of different attack vectors with DNS, and so we'll see that as another issue. And then additionally, there's no CERT-based authentication. It's really just focused on if the CERT's valid, and maybe it chains up to a trusted CA. And then you can enforce in TLS, and you can overcome some of these challenges with Mailflow connectors, but they're not fully addressing the challenges. And then we get introduced to MTA STS and SMTP DANE with DNSSEC. So we're going to do some deep dives into both of these, but we'll set the stage right now and say that MTA STS is a sister technology to SMTP DANE with DNSSEC. They're both focused on mitigating downgrade attacks and man-in-the-middle or adversary-in-the-middle attacks. And they provide that CERT-based authentication. And MTA STS is a little bit more lightweight compared to DANE with DNSSEC, and we'll see that in the coming tech deep dives. Okay, I'll look at the MTA STS roadmap. So for outbound, this is done. This is on for all of our environments. MTA STS and DANE are both preemptive, so they're doing validations against the destination before an email is sent. And so it's a proactive security check before the email has been sent. And so we're doing these validations on the outbound path to organizations that you all are sending to. This is on by default, and there's nothing that you have to configure for this to work. We're working on an EAC report that's going to detail outbound MTA STS and outbound DANE metrics. and that will be available later this year. It's going to be focused on success and failures to help the admins. And then for inbound, this is done and available for all environments, but there's some configuration required. And so that's why I put available for all environments as opposed to just on by default. And then we are also working on a remote connectivity analyzer module. So that's going to help with debugging and validating destination configurations for MTA STS using Exchange Online's behavior. And that will be available later this year as well. A look at MTA STS under the covers. So STS stands for Strict Transport Security, and it's really about establishing encryption support and the policy for how encryption can be used with your inbound mail for a domain. And it's published via two mechanisms. So the first one is a specifically named TXT record. And so this is available at the _MTA-STS, and then just your domain, and then the top level domain. And the contents of the TXT record is the policy version. So the version is STS v1. The version v1 is the only version supported right now. And then the policy ID. And so this is just a number that is unique to your domain. And I think we're seeing folks use the timestamp for whenever they updated the policy, because it's really just used for signifying that the policy has been updated so that folks will go and fetch the updated policy. So you'll change the ID when you make an update, and then people know to go and grab the new policy. And then the second piece of infrastructure that is required for MTA STS is a HTTPS secured MTA STS policy for the domain. And that needs to be available at a specific URL, the MTA-STS domain, and then top level domain, and then the .well-known URL. At this URL, there should be a TXT file or a JSON file, and it's going to just have these 4 fields that I'm sharing right here. It's going to have for either of those files, and it's just containing only the policy contents. And the policy is first, contents is first the version, and like I said, STS v1 is the only version supported. And then the mode. So there's 3 different mode types. The first is testing. And so this is whenever you're setting it up and validating the configuration, and it lets validators that are using that config know that this is just a test config. If a validation fails, please go ahead and send me the email. And then you can flip the mode to enforce once it's working, and then that's whenever validation results are honored. And if a validation fails due to a misconfiguration or due to an actual attack that's happening live, then the email is not sent. And then you can also use a mode set to none, and that's whenever you're deprecating the policy, and it just means to ignore the policy. The third field is the MX name, and so this is a name that we have to find on that destination email certificate whenever Start TLS is issued and we receive it. So we're looking for this name, and this is where the cert-based auth comes in. And it's also important to call out right now that the wildcard that you see, this is a policy configuration that's specific to Exchange Online customers. So you can use this to secure your inbound mail flow to Exchange Online, but you can't just take the wildcard and run with it as a general best practice, because there are scenarios where you can't use a wildcard in this particular field of the MTA STS policy. So this is not general guidance, it's specific to Exchange Online. And then the max age is just the length of time that the policy should be cached. It's also important to note that MTA STS is not implemented with DNSSEC, but it does have some additional protection around the MX record lookup. It's mainly focused on the downgrade attack prevention and focusing on that. So there's a lot going on this slide. And so I want to step back and just look at the architecture first. And we see just a client on the left. This is just someone trying to send to Contoso.com. Contoso.com is an Exchange Online customer. They send, we manage email for them. and they have enabled MTA STS on their domain through their registrar, like whoever their DNS provider is. And so we see that up on the top right. That's their DNS infrastructure. It's their domain, contoso.com. And then on the bottom, or sorry, the middle right, we see the web policy, the web hosted policy. Doesn't have to be a typical web server. It could be some Azure services like we're going to see from Denis. And then on the bottom right, we'll see Exchange Online. And okay, yeah, and now we can go ahead and go into the flow. So it just kicks off with a DNS query in step 1 for at contoso.com. This is going to be an MTA STS enabled query, so it'll fetch the additional TXT record. It'll grab the records and from the contoso.com name server and retrieve them and then send them back to the client. There's some additional lookups for the A record in mail.protection.outlook.com, but I don't want to focus on that right now. So we're not looking at every single thing that's happening. We're focusing on just the MTA STS steps now. So with step 4, we see the HTTPS request to the web server to get the MTA STS policy at that well-known URL. The client holds onto the policy, and then that's whenever it actually connects to the Exchange Online front door. So it'll issue start TLS, and it'll grab, the Exchange Online front door will then return the certificate. And that's whenever the client is able to look at the certificate and then validate that the name that I talked about earlier was available in that certificate, was found in that certificate. And then that's whether or not the validation is passed. That's how you know if you're talking to the right email server. So this is kind of the overall flow. And we are definitely looking at only inbound because that's the flow that is going to require steps on your part. And so I'll go ahead and kick it over to Denis, who's going to actually show how you can use some Azure services to configure your inbound MTA STS. And because we're already doing the outbound validations on by default. So I'll go ahead and turn it over now to Denis, and he's going to show us how we can configure inbound.
Yeah, thank you, Ian. So let me share my screen. Okay, so I hope that you all can see my screen, right? Just to be sure.
Yeah, we can see it.
Yep.
Okay, cool. So the goal of this demo is demonstrate how we can deploy our MTA STS policy through static web app, Azure static web app, because we know that many customers don't want to have a web server, just to publish the policy and so on. So the goal here is demonstrate how you can do that, but not only using static web app, because at the end of the day, we need to host the policy somewhere, right? So in this case, the requirement will be hosting the policy on Azure DevOps. So the first thing here, we need to be sure that we have an organization in our ADO, and I already created one, call it Contoso Corporation. And we also need to have a project, in this case, it's called MTA STS, already created. So let's check about the repository. So once you created your project, the repository will be created by default. In this case, I created a new one, call it Mac demo, okay? And as you can see here, I already have all the folders, I already have my policy, everything is ready here. But obviously, if you create your repository from scratch, it will be empty. So the question is how we can create all this structure. So first thing, you need to clone here this to your desktop. And when you click on clone, you should be able to see the IDE. You should be able to choose your IDE actually. In this case, we are using Visual Studio, but you are free to use, VS Code or Android Studio or Eclipse or whatever you prefer. So let's open our Visual Studio just to show you how it looks like. In the Visual Studio, once you clone this, you will see just obviously the repository name here. It's called Mac demo. Then we need to start creating your folder app, which it's called here home, but you are free to use, root, web, or whatever you prefer. In this case, once you created our app folder, we also need to create the next folder that should follow the MTA-STS URL path, right? So as Ian just explained it, we need to create a folder called .well-known, and then we can create our policy inside well-known, which will be called mta-sts.txt, okay? So it's not a big deal. You just need to create the folder path, and then you create your policy inside well-known. The last thing that actually is not required from the MTA STS perspective, but it's required by Azure DevOps pipeline. We also need to create inside the home folder an index.html, just to be sure that our deployment through the pipeline will run properly. So in this case, as you can see, there's no secret here. I'm just copy and paste a piece of HTML code saying that in the body that this is the MTA static website index. Okay, so you just need to create this just to be sure that your pipeline, your job will run successfully. Once you are done, we just need, as any other Git repository, we just need to commit this and then push to the master, okay, push to the main. So now let's turn back to our static web apps. And I will just pretend to create a new static web app because actually I already have one here with my domain binded, but let me just show you how to create a static web app. This is a very straightforward process, not a big deal. So let's start with the name here, like MTA-STS project. And then deployment type, I will keep this as free tire. And in deployment details, the source will be Azure DevOps. Then the organization, as I told you before, will be Contoso Corporation. Project is MTA-STS. And the repository is the McDemo, which is hosting our policy. Branch will be the main. And in build present, we can just pick Angular framework. We should be fine with that. And this is very important field, the app location. We need to be sure to type here exactly the root folder that we decide, to be the app location. So in our case is home. Then you can review and create this. As I told you, it's not a big deal. And I will turn back to the MTA-STS static web app that is already created here. And once this static web app is created, the first thing that we should do here is manage the deployment token. Actually, we need to copy this deployment token because this will be required in our pipeline to properly deploy this website. So once we copied this, let's click here in pipelines on ADO and create a new pipeline. So we will choose Azure Repos Git. And then we should pick our repository that is hosting our policy. Starter pipeline. And the first thing to do here is add a variable to host our token that we just copy from our web app. So click here, new variable. Let's just provide a name to this variable. It will be called token. And let's just paste the token here. We can save this and we can run the script that will deploy the website. In this case, I already have the script here. Let me just copy and paste and you can see this. Okay, so this is the script. It's not a big deal. The most important thing here is the task. We are deploying an Azure static web app. The app location must be exactly the folder that is hosting all the projects. So in our case, it's home. And here in Azure Static Web App API token, we need to be sure to select exactly the same variable name that we just configured here, right? So this is the syntax that we must use, and we should be good to run this script, right? And once the job is finished, I will not run this because, you know, it will fail because I already have this web app in use. But anyway, once the script is finished, you can come here in environment and you should see the status as ready. Okay, if you want to be sure that everything was successfully deployed, you can click here on browser and you should be able to see that index file that you configured here. Exactly the same value that we configured in the index value. So we can also obviously browser to the MTA STS policy. So the path is, well, num/MTA STS.txt. And we should see our policy created. But obviously you can tell me, okay, Denis, but the domain is still that default domain provided by Azure. It's not my vanity domain. That's right. We still need to do the last step here. So once that we know that everything is working fine, we can come here in custom domain. Yeah, there is this little bug that sometimes is grayed out. We just need to refresh the page. Okay, there you go. We just need to come here, click in add. We have two options: custom domain on Azure DNS if you are hosting your domain on Azure, or custom domain on other DNS, which is exactly our case. So I'm running my domain on a third-party DNS. So in this case, let's suppose that my domain is Contoso. What I would need to do is type here mtasts.contoso.com. Then it will tell me what is the CNAME that I need to create on my DNS. First of all, to prove that the DNS belongs to me, right? And second, because obviously I need to have a CNAME to translate that name, the MTASTS name, to the Azure, because the Azure at the end of the day will host my policy, right? So once we create this in our DNS, it can take some time, like 24 hours, but pretty sure that it works. We just need to create this, click in add. And once that we click in add and everything is validated, you don't need to care about the TLS because Azure will issue a certificate for you to cover the MTA STS subject. So you don't need to care at all about TLS. Everything will be done automatically. And once we're done, we can validate that your policy is properly configured. Type in mtasts.your-domain, like in my case, Signorelli, Denis.com. And there you go. As you can see, the policy is working fine. So once that we know that the policy is properly configured, the last step that you need to do is configure your TXT record, because the TXT record is the record that will tell to every sender that your domain support the MTA STS protocol. And this is the last step. So you can find this in this documentation, which is the official documentation. And by the end of the week, probably we will also have this procedure that I just explained, publish it in this article. So if you have any doubt, you can just come here and this document and download this procedure. Okay. Yeah, that's it. And if you have any question, feel free to drop in the chat, and I will be here also in the Q&A if you have any question. Thank you very much. And yeah, go ahead, Ian.
Thanks, Dennis. So we are working on offering like a automated version of deployments, but that's how you can kind of quick and dirty get it done. Okay, yeah. Again, thank you so much, Dennis. Please go ahead. We're recommending everybody to take those steps as soon as they're ready. It's lightweight and it's offered in the service, and so as soon as you're ready, please go ahead and implement these. Cool. Okay. So now moving into SMTP DANG with DNSSEC. So this is also rolled out for outbound for all environments, and we're doing the validations by default for all environments. And there's, like I said, that Exchange Admin Center report that's coming later this year. And this is going to include the outbound metrics for NTA, STS, and DANE with DNSSEC, and for successes and failures. And then we're working on inbound. It should be available fall of next year. And we also have available right now a remote connectivity analyzer module, and that is done and available through the remote connectivity analyzer test site. Okay, so let's dive into DNSSEC. So DNSSEC was introduced in 2 RFCs. So it's kind of providing general DNS security, and specifically it provides authenticity of DNS records, that you are dealing with you've connected to the right name server, a name server that's allowed to give out records for this domain, and so you know these are authentic records. And then it also provides guarantee that the integrity of the records is high, that the records were not tampered with in transit. Does both of these things through cryptographic signatures and X.509 certs, and introducing a handful, honestly, about 20 some odd new record types. And I'm only going to talk through 3 today, because these are the ones that are really required to understand the core concepts of DNSSEC, which are zone signing and then the chain of trust. So the RR-SIG record, there's going to be an RR-SIG record per record type that is requested. So if you ask for an A record and a TXT record, then there's going to be 2 RR-SIGs, 1 for each record type. There's going to be the DNS key record, and so these are there's two flavors of DNS key records, as if DNSSEC isn't confusing enough. And the first flavor is the zone signing keys. And so these are used to sign usual DNS records like A records or MX records. And then there's the key signing keys. And so these are used to sign the zone signing keys. And it's a way of validating if the zone signing keys were compromised or tampered with in some way. So those, the RSIG and the DNS key records, those are used for the zone signing. And then the DS record and the DNS key records, those are used for the chain of trust. So the DS record contains a self-signed hash of the public key signing key record in that DNS key record. And so it's all going to come together in a few moments, but that's the kind of introduction. And now we'll go into what zone signing looks like. So what is, people say, oh, we're signing on, we've got this signed zone or a secured zone. What does that really mean? And so we'll pause and look at the architecture. So we have a client on the left. They're just trying to go to a web page for contoso.com because I wanted to keep this simple. There's going to be a DNS resolver in the middle. And this is a resolver that's able to perform what are called resolver side validations. And so it's doing the validations for the client. You can have the client do its own validations, but typically we're doing resolver side validations to decrease network traffic. And then on the right, you see the authoritative name server for contoso.com. So this is able to answer questions about contoso.com and respond with authentic records because it is a DNSSEC enabled zone, and it can do the DNSSEC record generation, and then the DNS resolver in the middle, like I said, can do the validations. Okay, so step 1, we're just going to www.contoso.com, asking where is that? It's going to include a flag that says this is a DNSSEC enabled query, and then it'll go to that DNS resolver. The resolver asks questions from other DNS servers on behalf of the client, and so it'll find the contoso.com name server, and it will ask it, where is www.contoso.com. It will also include information that lets that authoritative DNS server know that it's a DNSSEC enabled query. And so it's going to return the DNSSEC records. And so in step 3 on the bottom right, we'll see the creation of an ARRSIG record on the fly. You can do this like you can calculate all these rsig values ahead of time, but it doesn't work if you have changing DNS records. And I think a lot of services do, and so we're signing on the fly. And so at the time of the query, this record's being generated. And so they're taking the A record for the www web page. They're taking that A record and they're signing it with the private zone signing key. And then the hash of that is being stored in the ARRSig record. And so that's the contents of that ARRSig record that's being returned to the DNS resolver. So we're also returning an A record and a DNS key record. And that specific DNS key record being returned has the public zone signing key. So in the RRSig record, the A record was signed by the private, and then it was stored in the RRSig. Now we've returned the public kind of pair for that, the public side of that private public key pair. And then that's being returned to the resolver. And so we see in step 4, where the resolver takes that A record, it was just given, and then that DNS key record that has the public zone signing key. And then it signs that A record, and then the result of that is seen in hash 1. And then it already has the hash from the A RRSig record. And so it'll compare those hashes. And then assuming that the hashes match, then the A record is returned to the client with what's called the authentic data flag set to 1. And so that means that you're dealing with authentic records. So this is kind of a pattern for how you secure a single record type. And then we'll need to, repeat this process for other record types. And so, you have to secure the DNS key records. And additionally, we've kind of created an island of trust by saying contoso.com is secured. But we had to find contoso.com because DNS is hierarchical, right? And so how do we get referred to contoso.com so that we know we can actually trust that name server? Because this is really, really the next step, and that's what the chain of trust brings in. So how do we create trust between zones and kind of bringing this into the full picture of a messy spaghetti bowl of DNS? So on the right, we see the .com name server in the top right. And that's, a parent zone, the .com zone. And then we see below it, contoso.com, a child zone. And then we see in the middle, the DNS resolver, and then on the left, the DNS client. And so all of these are in this, in this diagram, all of them are DNSSEC enabled. They can handle the queries, they can do the validations, they can preserve the flags like that authentic data flag I talked about. And then, all these RRSig mechanisms are happening along with underneath the covers. So this is how we're able to securely refer traffic. And so this is introducing the DS record that I talked about. And so let's look closely at the .com zone's content. And we see this DS record that has a 0 next to it in a circle. And so that is the self-signed hash of that public key signing key in the DNS key record in contoso.com. So that DS record is the self-signed hash of that DNS key record down in the contoso.com zone. And so, right now we've got, so actually I'll go ahead and talk through the flow now. So with the client, we asked, where is www.contoso.com? The DNS resolver goes to the root and then gets referred really to the com zone. But I just wanted to talk about the com to the contoso.com referral because that's what you'll need to do to configure DNSSEC for your domain. So you'll see there's a query in step 2 for contoso.com. They're going to ask for the name server to find the the NS record, so it can find the name server for contoso.com. And that's going to be, secured with that RRSig pattern I talked about earlier. I'm just not including that so we can focus on the DS and the DNS key portion and the chain of trust portion. So it'll also grab that DS record that we see for Contoso. And then in step 3, it will, go to contoso.com, ask, where is www.contoso.com, but it'll also ask for that DNS key record, that public key signing key. And then we look up in the top in step 4. And so the DS record already had the self-signed hash for that same DNS key record. It's in the COM zone. We trust the COM zone. We know it's a trusted island kind of thing, right? And then we've been, referred down to contoso.com, and we look at the DNS key that contoso.com returned to us. We sign it with that same DNS key. So we use the DNS key and sign itself. And then we look at the output of that, and that's in hash 1. And then we compare it with what was in that DS key in the .com zone, which we did trust, right? And then we compare the hashes. And if the hashes match, then we know, okay, we trusted the COM zone. The COM zone sent us to this name server. So we can trust this name server. So that's how we're able to securely refer traffic from a parent domain down to a child domain. And that what pulls it all together for DNSSEC. I'll just take a few seconds and grab some water, since that was kind of some heavy content. Okay. So SMTP DANE. So DANE stands for DNS-based authentication of named entities. And it's also encryption support published through a new DNS record type. This is the TLSA record. So the naming convention for the TLSA record is _25._TCP, and then the MX host. And so in this way, TLSA records are tied to MX entries in DNS. And so you can have, one MX that's secured by TLSA and then another that's not, and that way you have some fallback if you want. And then, MX host and then domain and top level domain. We see on the right a 311 and then a hash, right? So the 311 are specific to the TLSA record, and they are enumerators. They describe what the sender should do with the destination email's cert once it has received it after the start TLS command. So it's going to snag some specific information from that cert. It's going to transform it by taking a SHA-256 hash of it, and then it's going to compare that with the cert info that we see in that hash. And it'll all come together in the next slide. And it is implemented with DNSSEC. So you have kind of the general DNS protection that I talked through earlier. And then now we see the full validation in the flow. So on the right, we see contoso.com, an Exchange Online customer that is using an MX record that points to this domain that y'all are not familiar with. It's called m365dnssec.com, and it's just a placeholder name to signify that we're going to be having a DNSSEC enabled zone. That's the bottom line. That's all I'm really focused on here, is that we'll have a DNSSEC enabled zone with an MX record that points to contoso-com's a record. So we'll look in that m365dnssec.com zone, and we'll see like I said, the A record for contoso-com, contoso.com's MX record. We'll see the TLSA record for contoso.com, and then just a DNS key record to signify that this is all underpinned by DNSSEC. And then on the left, this is just a client trying to send an email to contoso.com. And so we'll kick it off with step 1. There's a query for @contoso.com. The DNS resolver is going to find the contoso.com name server and get the MX record. It's going to do, like I said, all of the validations, all the DNSSEC validations underneath the covers, and as this is a DNSSEC enabled query. And then it's going to get referred, it's going to find that MX record and then reference the m365dnssec.com zone in step 3. And so it's going to be, and at this point, like, the client would have already asked also for the DANE record, so the TLSA record. So the resolver knows to grab that as well. And so it'll grab the TLSA record, the A record for contoso-com, and all the relevant DNSSEC records. it'll do the validations and then return the records to the client with the authentic data flag set to 1. If these records are not authentic, then this is where the validation really stops. There's no Dane without DNSSEC. That's not really implemented. So they have to be DNSSEC enabled, and then so in step 4 they are, and they're returned back to the client. In step 5, we see the client issuing start TLS to the Exchange Online's front door and receiving the certificate from that Exchange Online front door. And then in step 6, it is transforming the certificate based off of what the TLSA record told it to do. So it's grabbing some info from the cert, it's taking a hash of it, and then it's comparing that with what was stored in the TLSA record. So we trusted the TLSA record, right? It was from a secured zone, and then we're looking at the contents from the certificate and comparing it with that trusted record. And now we know, as long as they match, that we're talking to the right email server based on their certificate, and we have gotten there with authentic records. Okay, so in terms of some interoperability, today SMTP DANE with DNSSEC and MTA STS are treated equally. So if both are present, the validations for both have to pass, or the send is retried for 24 hours, and then assuming there's no change, then it fully fails the send. And we are looking at this, and we are considering making it so that DANE successes are not overridden by MTA STS failures, but we haven't made the update yet. And then in terms of a recap, so MTA STS is relatively easy to deploy and maintain. We saw that it's and the documentation that walks through, that's going to be updated, and it will walk through Denis's presentation, we'll see that it's an easy walkthrough, and it's pretty clear, and I think that it won't take more than an afternoon to configure, and it's really encouraged, like we're really recommending people to turn on to configure inbound for MTA STS. It's provided by the service for outbound, and we really want you to secure both ways. It does require extra infrastructure to host the MTA STS policy, but you get that strong protection against downgrade attacks and some additional protection for MX record lookups. Then we're just looking over at SMTP DANE with DNSSEC, and it's definitely heavier weight. It's more cumbersome because of the DNSSEC implementation, but you do get the additional benefit of the strong security posture against DNS and downgrade attacks. So. And we're looking to offer inbound, like I said, fall of next year. So definitely something to keep on the radar, that there'll still be some actions on your part in terms of securing kind of your contoso.com vanity domain. And so just some things to think about. But yeah, that's really everything I've got. Thank you so much. Thank you, Denis, for an awesome walkthrough, and open to Q&A. The documentation update is coming in the next few days, next few business days.
Hey, Ian, there was a question about the inbound support for DNSSEC, especially, well, actually two questions. One, do you know when Azure DNS is going to be supporting DNSSEC? And then two, the timing for when we are, I think you already mentioned mid next year for inbound support for DNSSEC and DANE for Exchange Online, but if you can confirm that and talk to the Azure DNS for what you know.
Yeah,
or what you
right.
can and can't say.
Exactly. Yeah, I think we're still targeting that Q3 next year.
And is that for Azure DNSSEC?
That's for Exchange Online to support inbound SMTP DANE with DNSSEC.
And so presumably Azure DNSSEC would have to support it before then. I'm sorry, Azure DNS would have to support DNSSEC before then, or do you have any idea when Azure DNS is going to be supporting it?
I don't know. I don't have things that I can share public for their plans for inbound support.
Okay, fair enough.
Yeah, thanks.
Oh, David asks, any thoughts on TLS RPT? Sean, I think you
Ah,
got you or Ian.
oh, yeah, Sean, go ahead. Yeah, I know that. Yeah. Well, I think Sean maybe is having trouble with the mute button. So we are working on TLS RPT, and we are sending and receiving TLS RPT reports. And so that's that's definitely happening. We're part of the ecosystem for that, and we're looking at an Exchange Admin Center report that would allow a tenant to see TLS RPT reports for their domain. If that's something you're interested, please go ahead and put it in the chat. But yeah, we're a part of TLS RPT, but we haven't started surfacing the metrics to tenants yet.
Yeah,
Yassine had
basically what Ian said, we've fully implemented it and it's working together with MTSTS. But we're looking to improve the experience, because at the moment customers would have to receive their own reports in an inbox and try and parse that JSON.
Yassine had a question earlier that I missed. Does DNSSEC work with split horizon DNS? Ian, do you have any
I'm honestly not sure what exactly split horizon
DNS is?
Yeah. Can we take that person off mute and we can have some dialogue?
Yeah, Yassine, you want to come off mute and
Yeah, if it's all right with them.
Sure. Can you hear me okay?
yeah.
So yeah, split horizon DNS is basically when you have the same domain, like in AD and on public, like say contoso.com is the same domain in AD and the same one you have in public for email and whatever. So does that mean like you need to enable DNSSEC on AD first and also on Microsoft 365 or both or just one?
Yeah, based off my current understanding, it would be only on the public side of that domain. I may need to do a little bit of research and follow up though, because that's not something I'm familiar with.
Tim had an interesting question. What is the vector that is being protected against? If you want to take a look at that one, Ian, coming in at 9:45.
Yeah, what is the vector that for SMTP Dane or for MTASTS, Tim? Okay. So what is yeah. SMTP Dane. So it's got it. How would the sending MTA know? Yeah, it is in that scenario where someone's spoofing DNS and returns an invalid MX. So the sending MTA would include some flags that are included in eDNS, which is extended DNS. And so it's something that has to be implemented whenever you want to perform DNSSEC validations on the client and the resolver side. So there'll be some additional information that the client will ask for, and it's going to say, I need DNSSEC, and I expect DNSSEC. And so yeah, that's really it. And then the resolver is going to start looking for DNSSEC enabled DNSSEC records, and then if the records aren't there at all, then it's going to assume that the domain is not configured for DNSSEC, and it's just going to skip the validations. It won't it won't freak out whenever there's no DNSSEC records. It's just that if they're there, it's going to do the additional validations.
Hey, Ian, Joseph has had his hand up for quite a bit, patiently waiting to
Sorry,
speak. So
yeah.
sorry about that, Joseph. My apologies. Joseph, you want to come off mute and ask your question? Joseph?
Oh, I
There
think
you go.
maybe that was a mistake.
Oh, okay. No worries.
Sorry about
Well,
that.
glad we didn't keep you waiting. That's no problem at all. Thank you.
Thanks, man.
Does MTA STS or DANE replace current methods like SPF, DKIM, DMARC? So no, it does not replace them. So DKIM, DMARC, and that suite, those are after the email's been sent and validating against the sender. So these are used to validate before you send an email if you trust that destination. So it can prevent, data leaks and such.
Heinrich had a question. Where can I find info on the Orca scripts? I think Dennis, is that targeted at you? I'm not sure what the ORCA
Well,
scripts are.
Orca, as far as I remember, was a script developed by Cam, which provides, actually scan all the configurations that you have in EOP and Defender, and then provide a kind of report with the best practice that you should adopt, that you should change, and so on. I'm not aware if we are checking MTA STS through Orca script. Do you know about that, Ian?
So I'm not familiar with Orca scripts. I was looking in the chat. Can you repeat that, Dennis?
Yeah. Well, let me try to find this script, but basically it's a script that it's pretty much what the configuration analyzer is doing nowadays on the security portal. So basically the script will analyze, all the configurations that we have for Defender and EOP, and then provide you a report on what should be mitigated and what should be improved, right? But I don't think that Orca is, getting configurations about MTA STS.
Yeah, I'm really not sure. I'm not familiar with Orca whatsoever.
Okay, we'll just take a note of it and maybe we can get back on that later on.
Yeah, the
Ken
plan
had-
in, sorry
Go
to
ahead.
interrupt, Kevin. The plan
Sure.
in is to create the remote connectivity analyzer to check MTSTS configurations. So
Yes, definitely.
that is something that is in the works, and so adding those checks also to the Orca scripts could be done maybe after that.
Cool. Ken here had a real common question that we see. Does either MTA, STS, or DNSSEC with DANE replace any current authentication methods like SPF, DKIM, DMARC? Ian,
Right,
do you
yeah.
want to take that one?
Yeah. So right, the DMARC, DKIM, SPF suite, those are after the email's been sent, validating the sender, and these both are before the email's been sent and validating that you trust the destination email system that you've connected to before the email has been sent.
So SPF, DKIM, DMARC, trusting the sender, DANE, DNSSEC, trusting the recipient side, receiving side.
Exactly. Yeah, exactly.
Key difference between the two.
Yeah, so you'll want to use both, right? This
Yep.
is not a replacement for SPF, DKIM, DMARC, not at all.
Oh, David has more info about SPF, DKIM, and DMARC in his session, Protecting Mail Flow, a Practical Approach. Definitely recommend checking out Dave's session. He's a pro, been around a long time. I'm sure you all know him. And so it'd be great to check that out. I hope I can do that as well.
And then I think Denis has a session right after this where he's going to do a live downgrade attack and show how it works, if that's correct, Denis?
Yeah, exactly. It's actually in 5 minutes.
Yeah.
Oh,
So
okay.
yeah, we will demonstrate. It will be a very interesting demo. So we will demonstrate
Cool.
how man-in-the-middle attacks works, and how you can protect yourself using MTA STS.
Yeah, I've got a session coming up in a half an hour myself, recent and upcoming transport things. But God, if I could, I would go to Dennis's session instead. So not that I'm trying to dissuade people from showing up to mine, but Dennis's session sounds really awesome. Go for it, Dennis. Have a good
Yeah,
session.
thank you.
Thank you
Thank
so
you.
much.
Thank you, everyone.
All right.
Yeah, thank you, Denis.
Hope we'll see you in the Ask the Experts later in a couple hours. Sounds good.
Yeah,
Thanks,
definitely.
Dennis.
Thanks
Yeah.
everybody for joining.
Definitely.
Have a good
Thanks,
day.
everybody.